Hello guys, welcome back to another video. So in this video, we are going to be analyzing Morocco earthquake data with the help of Sentinel-1 SAR data, and we will be using interferometry to visualize the earthquake data. So we will be creating this rastered image from the SAR data and visualize the earthquake affecting areas. So first we need to download Sentinel-1 data for this analysis. Go to ASF official website, click find data, then vertex, and you will be redirecting to this ASF data search vertex. So we need to draw a polygon for our study area. Next, select Sentinel-1. So Morocco was hit by a 6.8 magnitude of earthquake in 8 September. For pre-data, we will be using before the date of 8 September. For post-data, we will be using after 8 September. So in here, I will be selecting the start date to 16 August. Next, we will be selecting L1 SLC data, that is single look complex data. For SAR Interferometry, we need the SAR raw data. Then we need to choose a direction so we can use the same image. In here, I will be choosing ascending. You can also choose the descending data as per your requirement. Make sure you use the same data, that is either ascending or descending. Then select the tile of your study area, and each tile have two numbers, that is the path number and the frame number. For this we will be using path number 154 and the frame number will be 489. We will be present with same image with different dates of data. So for this tutorial, we will be using pre-data 30 August and post-data will be 11 September. So we can do the interferometry. Click download SLC. To download ASF data, you need to have a Earth data account. If you do not have any, you can register here in free. Then log in with your user credential and download the data. After downloading, open in Snap. Snap is a open source SAR data image analysis tool which can be downloaded in official website of Sentinel image. Click file, open product, then import the two dataset. We will be using a small portion of this data because our machine is not that much heavy. So in the world view, you can see the bounding box of the images. Next, we need to split this image. Go to split, go to S1 top split. Every Sentinel-1 data comes with 3 subworth and 9 number of burst. So we will be choosing only one subworth, and for this tutorial we will be using only VV polarization. You can also select the burst from the slider. Set the export directory. SAR data image analysis need a huge amount of free space of your hard disk or SSD. Make sure you use SSD for faster processing. So click run. So you can see here the three burst of images. We will be joining these three burst into one image later. Next, we will be applying the orbital file. Check do not fail if new orbit file is not found. Do the same thing with second image. Next, we will be merge these two images for interferometry. So next we will be back geocoding these images into one. Add these images. Choose the default option and check output, deramp and demode phase. Click run. So we have a single image now. Next we will be doing enhance spectral diversity. Choose the default option and hit run. Next we will generate interferogram. In the processing parameter, change the coherence range window size to 20. So as you can see here, we have generated the interferogram, but there is some noise and the burst need to be merged into single image. So next we will be do deburst. Choose the default option and run. So it will merge these three bursts into one image. So this is the newly generated image. Next, we will be doing topographic phase removal. In the processing parameter, choose the default option and check output topographic phase band and output elevation band. Click run. So next we will be generating the square pixel because SAR image data does not have square pixel. So we can observe the image as a normal raster image. So go to multi-looking and change the range look to 8 and click run. So you can see here we have the square pixel now, and the image is much more visible and understandable. And the fringes are the interferogram. Detect the earthquake changes or earthquake effect areas by observing the fringes. The more closely the fringes are, the land has effect greater because of the earthquake. Next, we will be doing Goldstein phase filtering to remove some noise from the data. Change the APFT size to 128 and run. So you can see here our image is much more clear and it reduces some noises. From this you can actually see the earthquake effect areas and you can also export it. Next we will be seeing the changes of the land subsidence and convert this phase value to meter so we can measure the changes. So for that we will be doing unwrapping. Go to interferometric, unwrapping and snap HU export. Choose the default option. Change the number of rows to 1 and number of columns to 1 and the number of processor or the processor count of your PC. So I will be using the default configuration. You need to choose the target folder. I will be naming this snap.hu in my export directory. Next run it. Next go to this directory. You will have two coherence image, two phase image, one config file and a unwrap image which is format in HDR file. So we will be generating the unwrap image in here. To use snap.hu you need to install it in your computer so that you can run the command from the command panel. So open the snap.hu config file. In here comment the log file and copy the command above. Next, save the config file. Go to command prompt or open any terminal and type snap.hu to see if snap.hu installed or not. So to install snap.hu, you need to go to the official website, visit to this manual installation section and download for your operating system. So after downloading, extract the contents inside a folder. So I will be extracting in snap.hu folder. Go to this bin folder and copy the bin path. Next, go to your system environment variables so that we can access it from anywhere with the help of terminal. And if it successfully installed, you will be prompted with this. Next, run the command. This will take some time, so please wait to finish it. After finishing, it will generate a unphased image and the format will be .image and there is now a new image which is .hdr file and the next file is disk image, so that our command is run successfully and unwrap image is generated. Next, go to snap interferometric unwrap import snap.hu. Select the multi-log filter data for the read phase. Browse to this snap.hu folder and click unphase.hdr file, not the second one which we have generated. Check do not save unwrap interferogram. Add a prefix to the file name. So we'll be using UNW to distinguish it unwrap image. Click run. So you can see here it is a normal raster image and the fringes are gone. Now the pixel value has the phase value, but we need to generate the land motion with meters. Positive is upwelling and negative is subsiding. For that, go to interferogram, then phase to displacement. Select the unwrap image, click run. And the new generated image has value in meters rather than the phase value, as you can see here. Next, we will be georeferencing this image. So we will be using range Doppler terrain correction. Choose the default configuration and the projection will be WGS84. Click run. We will be also exporting the interferogram images. Next, export these images as GeoTIFF and you can visualize this image in any GIS software. We will be using QGIS to visualize these images. You can also export these as KMZ file, which is a Google Earth file, and you can directly visualize it with Google Earth. Next, we will be importing the displacement image in QGIS, and you can also do the color grading here and create a map which areas are affected by the earthquake. So thank you for watching. Please like this video if you like this, and if you want to watch more videos like this, please subscribe to this channel. Thank you for watching.